sophisticated monitoring system is an integral part of the smart circular bridges. Almost 100 sensors are constantly monitoring the structure and its material condition. These data not only guarantee the highest level of safety for the bridges. Combining the data with laboratory tests, valuable information is collected for the planning and optimization of further bridges and other structures. Today, I'm here with Ellie from Common Sense and Christof from the Free University of Brussels. Both are experts on structural health monitoring systems in the project. What is the intention of using a structural health monitoring system in smart circular bridges?
Well, in this particular case, considering that we are using a new material for a new type of bridge, the first purpose of the monitoring system is to collect the data to characterize the material behavior and the behavior of this bridge in real conditions. Considering then that we are talking about a structural health monitoring system, on a long term, the goal is, of course, to guarantee the safety of the bridge. And that's why we are continuously monitoring the condition of the bridge using different type of sensors.
And what exactly are you measuring?
We are using 3 different types of parameters. So we measure strain inside the bridge using fiber optic sensors. They are really embedded inside the composite material. Also, temperature sensors are embedded and spread around the bridge. And at the outer surface, we use accelerometers also to measure vibrations.
And what are the results you expect from these measurements?
Well, every type of sensor or every type of data we collect, we will extract different features. From strain sensors, we are extracting strain that will allow us to see how the deformation is under different loads, so pedestrians, cyclists, but also how the bridge will deform over time due to creep. On the other hand, we are with the vibration sensors, we are measuring dynamic parameters, such as the frequencies and mode shapes and damping values that characterize the dynamic behavior of the bridge. And all these parameters we will put in models to see if they change or do not change over time. And that must give us some information about the actual condition of the structure.
There's a real-time monitoring in the project. How does it look like?
Yeah, we have sensors inside the bridge, and on the bridge, they are connected to a system, like a readout system with a computer. We collect the data locally. We record all the data continuously, and this data can be transferred to external servers.
Yes. And once it arrives on the servers, automatically different algorithms are processing the data to extract those features and those parameters that we want to continuously monitor. And then those parameters can go into more advanced models, can go into dashboarding with alarming, and there we can indeed continuously monitor the condition and the safety of the bridge.
How is the safety of the bridge guaranteed?
Well, it's actually part of the project to understand which are the parameters best describing the actual condition and the behavior of the bridge. And then during the project, we will monitor those parameters over the long-term life of the bridge. But there's a challenge because we already know that the parameters that we intend to monitor, they do depend on the loading conditions, the people walking over it, bicycles going over it, but it also depends on the environmental conditions, such as what is the temperature, what is the humidity. So in order to really be able to distinguish normal behavior of the bridge versus abnormal behavior or changing conditions, we will need to train data-driven models to make this distinction. And that's part of the research project.
It's quite a new material. How do you correlate the data with the theory behind the models?
Yeah, in the project there are partners, like university partners, who are working on material level, so doing on component level and material level testing. This is first step. And the second step is building larger scale models, also with embedded sensors and other sensor types on top, which can then be tested dynamically, but also statically, so really static mechanical load tests. this data can then be used already to correlate with finite element modeling. So with models in drawings. In the last step, we have the real bridge, the full scale bridge, which is here in the factory. Also with all the sensors mounted and ready and connected. And then we do also the both tests, so a static load test and a modal analysis test.
What do you expect to learn on the long run from the project?
Yeah, the fact we today embed the fibers inside the material in different layers at different positions in the bridge, and not only at the outside of the bridge, in like done in other steel constructions or concrete constructions. We learn also from inside the material behavior, and we can also find defects on a longer term inside the material, and that's of course never done before.
Yes, and I think we can really say that these technologies, such as optical fiber sensors, who are becoming actually in cost lower and lower, are really an enabler today to learn faster how the structure behaves, how material behaves in real conditions. And that's what we are doing. We are making this bridge smart, so we are becoming smarter as well.
It's a public funded project. Who has access to the data?
Well, as I already said before, once the raw data arrives on our server, we will calculate certain parameters and we will push it to a dashboard, which is going to be open for public. And people will be able to download the data themselves if they want to do some have a look at it themselves. But mainly it's the goal that every partner in the project will have access to the data to do its own research tasks within the project. But as I said, it will be public. There will be a public dashboard. People will also, who are visiting the expo, will be able to go to the scan a QR code, go to the dashboard live, and immediately even see the effect of their passage over the bridge on those parameters on the data.
So that means it's also a point of confidence, building up confidence for new materials, which are important for circular economy and for carbon roadmaps. So thank you very much for both of you for giving us the insights into the structural monitoring system of the smart circular bridges. Thank you very much, Ellie and Christof.
Thank you.
Thank you.